Hello, everybody, and welcome to the second Software Design Simplified live stream. And today we're going to be covering programming by intent. So here's the agenda. I'm going to introduce the calculator challenge from John Crickett. So if I just put up this intro slide, this is you may not see this actually, people who are on Zoom. In fact, you won't see this. This is for the people on the stream. But this challenge is very kindly provided to me by a guy on LinkedIn called John Crickett, who does his coding challenges at codingchallenges.substack.com. They're an amazing way of learning programming and learning kind of algorithms and various other bits and pieces. And if I just show you codingchallenges.substack.com. He has now 28, possibly a few more different challenges that you can complete, and everyone's nice and self-contained, and he does a really good job of taking you through step by step how to complete these. So the one that we're looking at the moment is build your own calculator. Now, what I've done is I've gone to the web and I've downloaded from GitHub an open source calculator whose code is extremely challenging to work with, let's put it like that. So I want to just give you a very brief overview of that code right now. So hopefully this is a font size that you can all see pretty clearly. It's all written in Java, so yay for static typing, yay for Java. And we've got this humongous initialize method with all of this stuff going on. And then we've got a pretty big method called action performed with a whole load of stuff going on in there as well. And if I just hide these meeting controls, hopefully it should run. And here's the calculator, 1 + 1 = 2. So it's a program in Java, it's initializing a GUI, and that is the example that we're going to choose. We do have tests, so if we drop down here and we click this little plus or press Control F5, it's going to run all the tests, and you'll be able to see here, got various tests here, subtract 2 from 3, multiply 2 and 3, etc., etc. So that's where we're at, and we're going to use this as an example for programming by intent. So I'm going to explain the problem, which I think I have done there. The wider problem, though, is this method is humongous, and I don't know about you, but I start reading this and I get a headache very quickly. So if e.getSource equals function button 0, there's a helpful comment here saying addition, then, oh, wait a minute, if it's empty, what's text.getText? I have no idea. What's an expression? Those of you who were here last week will know that this expression is a class that we extracted that does the calculation. Basically, you type various things into it, and then at the very end, you tell it to evaluate, and it will bring up the result of the calculation. So don't worry too much about the details on that. But there's this text, set text, and even more confusingly, we've got this weird x = 0, x = 1, and then it resets to 0. I mean, what is x? It's a classic variable that doesn't really mean anything. So the problem is we want to make this code readable, we want to refactor it, and we want to make it so that we can make a change. So any questions about that before we get started? I know that's quite a lot to take in for those of you who weren't here last week. If nobody chimes in, I'll start explaining what is programming by intent. Programming by intent is meant to solve that age-old question of writer's block. If you're sat there at your monitor and you're looking at this humongous method and you just think, I don't even know where to start. You've got a change you want to make. And in this case, I believe it doesn't handle brackets. In fact, it does handle brackets. But there is a bug in this code whereby if you do 1 + 1 = and then you type 1, in fact, it does it now, but in a previous version, it didn't clear the display. And there's a bunch of other very subtle bugs. So let's say you want to fix some of those bugs, or you just want to get this in control. You want to make it so that you're confident in changing this. And we have tests, but I wouldn't know even where to start with this. So it's designed to solve writer's block primarily, and it's also going to give you better usability of your code. It can also be used to prevent mistakes. So what actually is it? I'm kind of talking around the topic here. Programming by intent is asking the question, what is the code we wish we had? What's the code we wish we had? And we write that code. It doesn't work, of course, because none of the classes, none of the methods are there. We write the code, and then we make the code work. So what some people do is they kind of start in the weeds of the problem, right? They tackle the problem piecemeal. So they say, oh, well, I want to deal with addition first. I want to deal with subtraction. Here we're going to do a sizable refactoring. So I like to think of it almost as a coloring by numbers approach. So I don't know if any of you remember this guy, you probably, or maybe a bit too young. I remember him. He was a painter dude who was kind of around in the 70s and 80s on TV. And he was really soft-spoken. And he used to paint like this. And he'd be like, we're going to put a little bit of color on the trees. And it's this nice, chilled out kind of vibe. There was another guy called William Alexander who was exactly the opposite. He was a very, very brutal painter. This guy was really friendly, really nice. And he's got this painting by numbers, coloring by numbers idea. What does that mean? Well, I've got a little process, and the steps will become a bit more apparent when we actually get into the nitty-gritty. So the approach is a little bit different if you're refactoring or writing new code versus writing tests. We're not going to be covering the writing tests scenario today. We're going to be covering refactoring. But I will say it's absolutely amazing for writing tests. I don't know if ever you've had that feeling where you're sat there, you want to write a new test for the piece of functionality that doesn't exist yet. Or maybe if you're not doing TDD, you want to write a test for some functionality you already do. If you're anything like me, you look at that blank screen and you just think, well, first of all, I don't know what the test should be called. So I kind of wrestle with that for a bit, 20 minutes, half an hour maybe, trying to rename it, trying to get the method name right. And then maybe I get something I'm vaguely happy with. And then we do our range act assert, where we set up the code, we make some kind of a call, and then we assert some expectations. But what should the setup look like? What should the code look like? How should it be called? What are we going to assert? And I've lost more hours than I care to mention on wrestling with these little problems. So it's amazing for writing tests because we can sit down and we can say, what's the test we wish we had? So we're not going to do that. We're going to go down the refactoring route because that's what we're doing. We're taking a piece of code that's quite gnarly and we're going to rewrite it. So if you don't have good enough test coverage, the number one rule of a doctor, do no harm. The number one rule of a programmer is first do no harm. If we don't have enough test coverage, we need to go and add more tests because otherwise we're not going to be confident in our changes. We don't want to break anything. If we do have decent enough test coverage, next thing I'd do is just look at, is this area small enough to be able to make a change on? So we don't want to be doing programming by intent over like 16 different classes. We don't want to refactor an entire swath of the code causing 20 other things to break. It's very bad. So we want to kind of shrink the area until it's quite small, but not too small. And I believe that's what we've got in this method here. It's, you know, it's maybe 100 lines or so, where it starts at line 133 and it goes on till line 217. So about 80 lines, and it deals with calculating numbers, which is, you know, it's a problem, but a lot of the work is done by this class in terms of the calculation. So we've got something that's relatively small and self-contained. So the first thing we need to do is gut the method. If we're refactoring, if we're writing new code, of course, there is no code there. So if we follow that line across, this is where we empty the canvas. So I'm imagining that our code, this code here, has lots of, like, it's a mess, basically. It's like Jackson Pollock, all sorts of stuff all over the place. It's not really arranged very well. We can't make sense of it, can't make head and a tail of it. The first thing to do is to gut the method entirely. So I'm going to invite Jake. Are you there, Jake?
I am.
Cool. I'm going to invite Jake to do this step with us. So I'm going to give Jake control. And Jake is going to have the enviable task of, he's just going to delete all of the code in this method. So it's kind of fun because you can just be really ruthless and just highlight it all and hit delete. And after every step, we're going to rerun the tests. Be interesting to see. Fearless changes as well. Delete all the code in that method and just see what breaks. Okay, so Jake, if you could go to the top right of the screen there, where it has the stop button. So you press that stop button first. Great. And then if you drop down where it says main, can you see the little drop down? And then click on tests. This is going to mean we're going to run the tests. So if you click the little play button now, and boom, loads and loads of things break. Any questions so far? What questions do people have? Feel free to chime in or not, as you are comfortable doing. By the way, the gray text here is just my super nifty GitHub Copilot trying to kick in, trying to tell me what to write. So that's not the code we have. Okay.
So hasn't deleting this code made our tests like irrelevant? So they're not like our safety valve anymore. Is that a good thing?
Sorry, what was it? What was the question again, Jake? I didn't catch the first bit. I was too busy talking.
Yeah. Now that we deleted the code for our tests, doesn't that, you know, it is not like a bad thing because we've not got the tests anymore to sort of
great question. Right, great question. I'll just take control for a second. Oh, hello, new person. I'll just take control for a second. If we go to the calculator test, our tests are perfectly still intact. So we've got, I should have said this at the beginning, we've got a whole load of production code here, but in the test folder is where all our tests live. So we've deleted the main method for the production code, but we've not touched our tests at all.
Okay.
And you'll see I'm doing all this kind of weird reaching into the calculator, and we'll tackle that problem another day, because this would be amazing for programming by intent again. I mean, I don't know about you, but I can't really make head and tail of what that test is doing there. But we're going to go back to the production code, and our tests are all failing, which is great because that's our safety net. Whenever we make a change, we're going to rerun the tests, and they're going to tell us whether the system still works or not. So let's go to the next stage. So we empty the canvas. This bit feels amazing because you can just take this massive hairy mess that until now was stressing you out, and just delete it all. It feels a bit too freeing in my experience. So it almost feels wrong to be so brazen. The next thing we're going to do is draw the boundaries. So we're going to kind of sketch out the code we wish we had. And after we've sketched it out, it's almost like doing it in pencil. And we're just going to write whatever we wish we had. And then once we've got it in pencil, we're going to go round it in pen. So the pencil stage is analogous to writing any code that we want, and it will not even compile, right? So we don't worry about compiling. We don't worry about the computer at all. In this phase, we're just worrying about human beings. What could we write that would be really nice and readable for human beings? And after we've done that, we will then paint in, sorry, this should be this diagram here. We will paint those areas in, as in we'll get all the tests to pass. So first of all, we write the code we wish we had, we get it to compile, and then we actually get it passing the tests. And you'll see these shapes here are not quite the shapes we planned originally. So whatever the code we wish we had is, we'll need to tweak it a little bit as we go to get the code passing, but that's okay. And I should say the object of the exercise here is not to finish. We're not going to do this whole task because it took me a good 3 or 4 hours. I'm just going to give you a little taste of each stage. So you can go away and you can ask the question, okay, what does this mean for me in my everyday work? So we've got our empty method here. Now this sometimes can be the rather challenging bit. So Jake, I'm going to ask you to write the code you wish we had. Now before you do that, you need to know a few different things. I should have really turned off that auto suggest. That wasn't a good idea. Number one is we have this expression. So we have 2 objects that we want to work with here. We have the expression, and we have what this is called, what this calls get is text. This text really is the display. So what we want to do is this action performed is called with an event. And that event represents the button that has been pressed on the calculator. So let's just keep it simple. Let's write the code we wish we had for 1 plus 1. 1 plus 1 equals 2. In fact, let's just try and find a test that will give us something nice and simple. Add 3 and 2. There we go. 3 plus 2 is 5. Okay, cool. So we're going to write the code we wish we had to try and make it, to try and make 3 plus 2 equal 5. So the way this works is a button has been pressed, action event has this method on it. In fact, don't worry about what action event has the method on. Let's just focus on writing the code we wish we had. And so this expression, we can actually set a number on the expression. And the calculator example is tricky because the expression holds a whole bunch of state in it because it needs to know what order to do the calculation in. And so it's going to look something like expression dot type number 3, expression dot type operation plus, and then expression dot type number 2 is s, and then display text dot output expression.evaluate. So that's the kind of thing that we're after. But of course, these things have to be called whenever this method is called. So it has to be done step by step. So Jake, over to you. Do you have any ideas about how we could, like, this would be all in one go, but of course we don't want to do this. We want to do each of these lines when a separate button is pressed. And so I'm going to just comment that out as reference for you.
So we're looking for some sort of method to write?
Yeah. So as an example, I might say if button pressed is 3, what do we want to do if it's 3?
Do we want to say expression of type number? 3?
Yeah, exactly. It's actually written the code for us. Look at this. Bonkers, what AI can do nowadays. So if the button pressed is 3, actually in Java, it should look like that. So apologies to those who know Java better than I do. If the button pressed is 3, then we're going to type a number. We don't want this nonsense here. If it's 2, we're also going to type a number. What does that leave us with? What's the other bit of the missing piece for this calculation?
Expression.
The expression, yeah. So else, if I can turn this off. Completions, thank you. If button pressed, what am I going to write here?
Maybe we're doing an addition, so we do the sort of plus.
Yeah, so we could say is plus. We're going to take the expression. There's a few clues in that drop down actually, because there's some methods that already sort of meet what we need.
Yeah, type operand plus.
Exactly. Type operand. I'm not going to worry too. Sorry, go on. What were you going to say?
Operation, is it?
Yeah, it should be operation. Good call. Type operation. So you can see how the expression currently has type operand, and it's very, very tempting to try and fit in with the code you already have, which is no bad thing often. But we want to stay steadfast, and we want to be like, would you say type operand? It seems a bit weird. Type operation plus. Another option, of course, would be expression simply type plus. Which of those looks better to you, Jake? There's no right or wrong answer here. Which it's just a matter of personal preference. Personally, which would you prefer?
I like type plus.
Yeah, cool. Equally, if we wanted here, we could do expression.type 3. So again, this is the cool thing about programming by intent. We have no legacy code anymore. We don't have anything tying us back. We have no tech debt. Well, we do have tech debt in other parts of the code, of course, but we have nothing pulling us back. There's nothing saying, oh, you've got to do it like this. You've got to have this kind of structure. You've got to have these arguments. We can make up whatever we want. And so whatever we say goes. So we can say, well, let's do type 3 here. Let's do type 2 here. Now there's actually, we're going to do 2 plus 2 equals. So that's the next case that we need to do. What happens when we hit equals? What do we need to do?
Expression.value.
Yeah, exactly. So what am I going to write here? We've not handled the equals, have we yet?
No. Else if button pressed is equals. Expression.type equals.
Okay, interesting.
Oh, sorry. We want to evaluate.
Exactly. We want to evaluate the expression. So this is going to be, I think well, we don't really want to do doubles, do we? We want to do decimals, but let's just keep it as a string for now. And what am I going to call this? What do you think a good name for a variable would be here?
Think an output, but we could probably put that in there.
Yeah, we can do output, totally. And again, another cool thing about programming by intent, you can just play around with ideas. You type output now, type the first thing that comes into your head, really. And then once you finish the first pass, you can say, oh, I don't actually quite like output. We can tweak it, we can finesse it. There's no cost to doing that because we're just dreaming now. So we've got the output, and the output is the result of our evaluation. However, we need to then output that onto the screen. So forget about the variables we have. What line would you write? What's an idea for something that's intentful, that's nice and easy to read?
Are we looking to display text?
Exactly. So we can just say display text output.
Okay.
Something like that. Other options, depending on how you're feeling this day, week, or month, could be output result. We could call this result. Output result is a little bit generic. We could use the word print if we want. Print output. Then that feels like it's kind of printing to a printer or something, or printing to standard out, which it kind of isn't. So we can, there's loads of options here we can play around with. Display text is pretty good. I quite liked, when I was playing around with that, I quite like the word readout. So you have a calculator and it has a readout. Readout dot output. Output seems a bit tautological, but we could do result. Readout output result, or we could do write result. At this stage, it's a matter of personal preference. But the thing I want to highlight throughout this whole thing is none of these trade-offs really matter that much. I mean, please feel free to agonize over these names, get it so that you're really, really happy with them, so that you can read this and at a glance, you can say, yeah, this makes sense to me as a human being, not a computer, a human being. But really, the object here is to be usable. That's the main objective with programming by intent, is that we're thinking about it from the human being's perspective. We're not coming into it thinking, what does the computer need? What does the compiler want? What does the test want? Blah, blah, blah. We're thinking about it as a human being. So it's amazing for writing really nice, well-crafted methods because it just puts you in the frame of mind of the client, and the client is the human being as well as being the computer. So I think we should leave that as that. So let me just see how we're doing for time here. Okay, we've written our intent, so we've got 25 minutes left. We're bang on time at the moment. So what we've got here is a sketch of the boundaries. We've got a sketch of how we're going to divide it up. But of course, the compiler hates us, as you can see from all this red. We've run the tests now. Oh no, won't even compile. It shouts at us, yells at us, all the rest of it. So the next step is, and we're not going to complete this because it would take quite a while, but we're going to make the compiler happy. We've made the human being happy first because we know we can read this as a human being and understand it. And so now we need to satisfy the computer. Programming is an exercise in communication and it has two audiences, the human being and the computer. And if you can cater to both audiences, you've won the game of programming, really. So I'm going to say the button pressed is a button. And we're going to say button create from event. And I'm wresting control away from you a little bit, Jake, because when you first do this, this is a bit of a head melter to get your head around. So you see how now all of these button pressed has gone green, that's progress. But we don't have create from event. What's really odd is the button exists already, which is not great because we're going to have to maybe subclass that or do something specific and say, this is a calculator button. Really, we want, wherever possible, we want things that the compiler doesn't recognize yet so that we can craft our own thing. What questions do you have that about, Jake, or does anybody else have? Okay, so this is where it gets kind of fun because I spend all my time in Ruby, and so we do not have an advanced IDE like this because we don't have types. So this is what I absolutely love about Java, C#, all these things. You can just say, yeah, go on then, create me that class. Boom. That's that bit done. Yeah, go on then, create me that method. Fair enough. Boom. Let's create this as well. And so this is us starting to paint in the areas. And you can see here, it's still shouting at us. We don't have any object that's being returned from this. This is a Boolean, but it's not returning anything, which is why it's got the little red missing return statement. But we're just going through every level, and we're just going to make it happy, make the compiler happy. There's an error with that. We create a method with that. And we're going to carry on doing this over and over again until we've got all of this that's gone green, basically. And it will be the sketch. I'll just do these very quickly. I don't have time to. So it still doesn't like type 2. Why does it not like that? Plus. Now it looks like we've got rid of all the errors in this method. So let's build it again. Missing return statement. So at this point, let's just do it quick, dirty. We can just return a new calculator button. The main thing here is to get the compiler happy as quickly as you possibly can. Don't obsess about it. We'll just go return false. Just do return false for all of these. I know it's wrong, and that's okay. Okay. Immediate evaluation expression is not abstract and does not override the method. So what it's now saying is you've stubbed all these out for our expression. We want all of these to be implemented. Run the tests. it does not override. So it's another one. It's for the other. Don't worry about what that means. I've got two implementations basically of different algorithms. Great. So now we're at passing compiler. The machine is happy, but it's behaving in the wrong way. What questions do you have about this? So we've now got solid lines, basically. And after that, we can start to color the lines in. And this is where we're not going to do the exercise on the stream, but this is where you would start to fill out the guts of each of these things. So we've just added this type plus. We need to fill that out with something that actually types plus in. We need to fill this out with type 2. So as if by magic, I can got some get tags here. And so I'll just check this out to show you. So this is what I had when I was sketching it out. In fact, I think it's just quicker to show you on Miro. So I started with this massive long method here. Like Jake, I removed it, gutted it. This was my first attempt at writing something that was semantic for a human being. Still things I'd do differently. Display buffer, is it really a buffer? It's really a readout. And then we come here, and this is with it actually implemented. This is with all the test passing. And you can see from here to here, I had to add quite a bit of stuff to make the test pass. But it's still in the same kind of shape. It's still got this kind of extended case statement. And I can still read it. I can still see if the button represents a number and the last character is equals, then do this. If it represents a number and the last character is not equals, then do this. From here, I then did a whole bunch of refactoring because I'm a little bit obsessed about such things. And now we have this, which I think is a huge improvement over the original. Feel free to disagree. So we're switching on the type of button pressed. If it's a number, do this. If it's decimal, etc., you can read. I'm not going to patronize you by reading it all out. This is one bit that I would still like to clean up. Enter operation, button press dot operation. Really, that should be expression dot enter open bracket. And then enter number and operation, button press dot operation. Blah, blah, blah. This is a little bit not quite as nice as I would like. So that might be enter close bracket with number, maybe something like that. And then we push to the display buffer expression dot evaluate. So I'll just show you the intent passing that I had. So here is what it looked like. And if you run all the tests, they all pass. So of course, this took me quite a few hours of drilling into each one of these and creating the contents of it. You can see each one of these is actually quite simple. One really nice thing about the design was I created an operation in enum for each different operation. So you don't need to rely on strings. And this means you can say, if it's add or subtract or multiply, it means you can do compile time checks, basically. Whereas if you're checking for strings, you might accidentally type a plus for a minus for an equals, and then your code wouldn't work and you wouldn't know why. So, and then of course I can just check out main. Check out main. This is the kind of the final, not the final. This is close to what I would say is a decent stab at it. What questions do people have? There must be some questions. I'm just going to look at the chat. My meeting robot is saying that I only have a few minutes left. We have 15 minutes left. What questions do people have about programming by intent or anything else here at all? If there are no questions, we can end early and I will give you back 15 minutes of your life. If anybody would like to have a bit of a go at this, please let me know, and you can take remote control of the screen. If nobody pipes up in the next 60 seconds, we will end the stream here. Feel free to reach out, by the way, afterwards over LinkedIn or email, and I will answer whatever questions I can. If you would like a copy of this chart here, these steps, please say the word. I can export it as an image and give it to you all. Hopefully it'll be of use to you. What questions do you have, Jake?
More just around when you're using this, so the flow chart, it's got some good cases. Like last week in the last week's stream, we were talking about doing a similar thing, but we were being sort of coupling and tightly coupling. How does this fit in with that? Does it go hand in hand?
Yeah, it's a great question. I love it because I'm not trying to plug you my book, but if you go down here, I wrote a book covering all of these kind of things, and today we've been covering this programming by intent. But the repeated frustration I had as a junior engineer was thinking that each one of these things was separate. And it reminds me a little bit of dualism of body and mind without getting too philosophical. People like to separate out the mind from the body, like they're two completely different things. One has nothing to do with the other. Like somebody can be really supremely physically fit, and if they're mentally ill, that won't affect their physicality at all, which is kind of silly, really, when you think about it. The two are interconnected. And I found over the 15 years I've been doing this, all of these things are interconnected, and you push on one and it has an effect on others. So 100% programming by intent. Last week, for those of you who weren't here, we were talking about coupling. Programming by intent absolutely has an effect on coupling. And what I found in doing this exercise, and just refresh my memory really, is that when you're programming by intent, this is where the little tweaks come in. So when you just write code, as we had, you and I had there, Jake, that's just kind of naive and it doesn't actually have to work, you can dream whatever you want up. And even when you're getting the compiler to say, yeah, it's okay, you kind of get to this point relatively easily usually. But the point where you actually start filling it in and making the test pass and making it actually do things and do the correct things, that's when coupling comes in. And you start seeing, oh, this thing over here is actually tightly coupled to this other thing over here. I wonder if there's some way of rejigging my intent to reduce that coupling. And sometimes there's not, and sometimes there is. Now, all of this seems extremely abstract, so let me give you a concrete example of this. If we were going in to these tests and we're going to refactor these tests to be more readable, what would I want here? I'd want calculator.print press 3. What we're trying to do, we're going to press the number 3. Calculator dot press plus calculator 2, and then calculator dot press equals, you get the idea. Instead, I'm having to do this jazz. Interesting. So why do we not have methods like that on the calculator is the first question. The second question is, but hang on, press 3. Dennis, please.
Just want to make a suggestion here.
Yeah.
If I may,
Please.
on the hello. Somehow it's always Guy with me. When we're doing these streams, say hello.
So cute. See, if you turn up to these streams, you also get.
Yeah, I don't know.
Keep
Somehow
babies.
on Monday, it's always Guy at this hour with me. Something that I would always recommend, and I'm really trying hard not to steal your show, so I'm pulling back because I love your time management.
I should say, everybody, Dennis is a lot more experienced than me, so I generally defer to his experience. Go for it, Dennis.
Something that I noticed, let's say, bugs me. So that it gives me that element of discomfort of taking a step of, so that kind of discomfort where I feel like we're catering more to the machine than to the human. Right? So, because if I think about this calculator, like a really old machine,
yeah,
like a punch card machine,
yeah,
then it is, you're essentially writing a sentence left to right.
Mm-hmm.
Right? But right now you are typing the sentence vertically. Calculator press 3, like calculator press plus. Right? But this is a stringly typed language. It is saying next character is 3, next character is plus, next character is 2. And whenever I see this kind of construct, I'm thinking, oh, this can be expressed as a string. Right? So I can say calculator, I don't know, sequence, and then I can say, I'm just typing in the chat.
Yeah.
You'll see it in a
Okay,
minute.
cool.
So I can say 3 plus 2 equals. Right? So I can imagine writing this. So, I can. So I am writing essentially, I can't copy paste from there. So I'm thinking, calculator, and then I might say, okay, sorry, calculator, and maybe I would say sequence.
Totally. So let me just close that meeting chat window, and then we can see what you're writing. Yeah, interesting.
Right. So I might say sequence and do exactly what you just did. 3 plus 2 equals. Because then it also makes it a little bit easier to understand when I do 3 plus 2, 0 equals, right? Because now the 2 and the 20 are a bit further apart. It might not be clear whether for a 20, do I need 2 and 0 or do I need 20 methods?
Yeah.
Right. So there is a singularity to every command is one character long. Right?
Yeah.
So this is a stringly typed natural interface. A human would be thinking about this as a left to right notation. So what I'm thinking is if you're following a AAA notation, so arrange, act, assert, I would say, given the sequence 3 plus 20, that'll be 1.
Yeah.
That'll be my arrange.
Yeah.
When my next press is equals, then I'm expecting, then assert the value text.
Nice. I love it.
Right, because I'm thinking, if I'm using a calculator, then if you entered, so this is a stable data expression. So if you enter a sequence and I enter exactly the same sequence, our calculators will show exactly the same result. Right? So given everything up until this point as a sort of event stream, I now want to test the last button press. So given that I'm in this state, when I press this button, then I want this result, right? So it makes it a little bit clearer on what we are testing. Because in the action performed, number 3, add button, number 2, equal button, I'm not quite sure what we're testing. Are we testing, do we know that there's an expression engine beneath? Are we testing the equal button? Are we testing the to button? Right, so that's what I'm sort of curious to see here. Whenever I see a testing paradigm that is testing this, a sequence of events vertically. I just wanted to make this suggestion that a vertical sequence of instructions is usually a sign of a rule engine, and rule engines can generally be expressed either as matrices or left to right string sequences. In this case, the calculator can be expressed as a single character left to right string sequence.
And it's funny you should say that, because I remember really early on in my career having a moment very similar to one that you just had, where somebody showed me, I wish I could remember the details, but basically they were telling me, they were suggesting that I laid out a test in a way that read on the screen visually a way that mapped to how we think of it mentally. And
how to explain it to someone.
Yeah, almost, but it was very visual. It was kind of like we had boxes and we had grids. It was something like that. And they were suggesting that we lay out, that's what it was actually. It was like an array of arrays. And we had it all kind of going vertically. So it just had like a string of numbers going down. They said, no, let's arrange it as it would be on the screen. So let's have a row here and then another row. Essentially, it's exactly the same thing, but you read it and you can map in your head, oh, I see, that's a row in the test, and that maps to a row on the screen. And I was incredibly I don't know why, but I was really against this idea. I was like, this sounds like a terrible idea, blah, 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 blah. And I just let it go for a little bit. And the person completed their thought. They wrote the intent on the screen. They made the test pass. And immediately I saw it. I was like, wow, that's so much better than anything I could have come up with. So that's the other thing I'd say is when you're doing this programming by intent, as Dennis has shown, there's always ways of upping the bar. Almost always, the first idea you had is not necessarily the best idea. And it's a great way for it. It's a great thing to pair with other engineers on and say, you know, can you think of a nicer way of doing this? Can you think of a way that's a bit more expressive, even more human-like than what we've got? And also through finding more and more expressive human-like ways of doing it, what we haven't really covered, and we've got 4 minutes left, is that a domain language starts to come out. So we could have something called sequence. And now you're like, okay, what's a sequence? Is a sequence calculated like? Maybe it's press button sequence or something, or enter sequence, or
just a formula perhaps.
Or a formula, yeah, absolutely.
Yeah.
So we can
play. If it's a math calculator, if it's a scientific calculator, I might be thinking of this as a formula.
Totally. And so you can play around with all of these ideas, again, in almost like a consequence-free zone, because you don't have to get anything working yet. Formula.
Yeah.
Does that make a sense? Maybe it's enter formula. And so we could maybe have a formula class that we pass in, or maybe we don't.
It's a very nice way of putting it. It's a great language.
So yeah, and then the cool thing is then we start to see, oh, right, the word formula is important for our domain. So instead of getting distracted with all of this action performed buttons and all this nonsense, which really isn't the core of the problem.
You can just get the text of the button, and then you can just
exactly
string it down into a formula.
We could convert that string, that formula, into a sequence of button presses as an intermediate step, maybe, but it's all wrapped up in this one method that we don't have yet called enter formula. And then you could hide that from the world. You could have button presses, and then you look at your button presses and you think, actually, this is complete nonsense. We don't even care what the buttons are. We have something to serialize the button presses into a formula and vice versa. There's so many things that can come out of this, and it's almost like you generate more and more ideas as you get more used to doing this programming by intent thing, and you end up with cleaner code that's even easier to read. And the other thing you're doing by programming by intent, and I'll finish on this, is you're training your brain to think like a human. And so often when we're writing code, we're thinking machine first. And over the years of lots of doing programming by intent, my brain has changed, and as Dennis has shown, it can change to a whole new level. You know, there's always ways of putting it in a more human-like way. And sometimes you do sacrifice a bit on the machine side by doing that. And sometimes you have to make abstractions that are, you know, you've got to make the decision, is that abstraction really worth the value in the human readable language we're getting? And everything's a trade-off. Right? Is there anything else you want to add to that, Dennis? Yeah,
I just wanted to highlight something really important regarding a sort of type of problem. See, because, and this goes to the sort of GNU Linux way of thinking, the sort of the BSD, the old school console pragmatism about how to write code that is simple, composable, very high cohesion, and it just, you know, every application just does one thing. LS does one thing, CD does one thing, you know, JQ does a million things, but it parses jQuery. And so this idea that if you have a programming exercise, and it comes up a lot in katas, where the input can be simplified down to a text input, and the output can be simplified down to a text output, then you're entering the domain of a large network of already solved problems, because that is the entire Linux ecosystem, right? Like that is the standard format for standard in, standard out, and then standard error for anything that's for the human, not for the machine. Right? So the Linux system already has this. Standard error is for humans, standard out is for machines, and then standard in is what the input was, whether that came from the human or from another machine. Right? So the calculator can also be expressed in such a manner. And most languages can, right? So whenever you come to this kind of problem, a stringly typed problem, you can always easily express it. And the real joy that comes with a text in, text out kind of system is that it is trivial to unit test.
Yeah.
You just create a bunch of, you know, data-driven tests, like an array. These strings go in, those strings come out, and it becomes pure and side effects free. And then you can reverse engineer it, and you say, well, when I send in this string, that's the equivalent of me pressing these buttons. And you might even have something to create it that even goes and presses the buttons based on the string that you put in.
Totally.
So it just becomes this universal, easy to parse human language, rather than still playing with the compiler. Like if you can take that step away from the compiler, you can keep the compiler stuff for the compiler, but then have a natural language of how to translate that, which makes your refactoring, you know, at the very highest level. You know, that's how the web works also. It's a string-based protocol.
Yeah.
That's why we created it.
Yeah. And
because we didn't want SOAP, because we didn't want the method call with the perfect version of which is the big int from Java 1.6 or is the big int from Kotlin. And we didn't want that to cross-compile over like a Java app across the internet. We want it to be string-based.
Yeah. And funnily enough, in John Crickett's example, he starts out with a command line version of the calculator. So if you create it as a string input, it means we can just chuck all the GUI away, and in 5 seconds you'll have a command line calculator. And then
although he did cheat a bit, he added spaces. And like a calculator doesn't have spaces, so he did sort of corrupt the example a little bit.
Yeah.
You know.
Anyway, we're gonna leave it there. Thank you everybody for your time and attention. Thanks, Dennis, for your input there. And thanks, Jake, for doing the examples with me and being my willing guinea pig. If you need any more help with anything, or if you've got any questions, feel free to reach out, and have a great day, everybody. Thanks for coming along. Bye.
Cheers, John.
Cheers, John. Thanks.
Thank you. Have a nice evening. Bye.
Bye.
Good evening.